Good morning, everyone, and welcome back to the ITS 2214, the data structure course. So based on the screen, you can see we're going to discuss assignment 4 of this session. Okay. If you recall, at the very beginning of the semester, we mentioned that eventually we want you to have the capability to deliver an end-to-end solution for a programming program. Okay, so if you have a question, we want to achieve an end-to-end. What does that mean? This is roughly exactly what our assignment 4 try to achieve. So we have a text-based problem description. And what we want is a working program. Working program. And if you look at the description of the project, we actually have attached a example input and output. So this is basically the user interface that your program needs to provide. So basically, when you start the major program and you're going to ask the user to input the data, it could be add or remove or mail or quit. And the concept or the grammar or syntax of the commands are described in this table and what you are supposed to provide. Okay. So basically, when we start from scratch, we need to solve two problems. So when we try to deliver from the text problem description to a working program, we need to actually resolve two problems. Okay, of course, the step 0 is to read the document and understand what we want. Okay, so we're not going to explain this part because the file is written in English, and for your knowledge, the file is written by a person whose English is his or her first language. So it's not written by a foreigner. Okay, so you should have no problem understanding the English, and I assume the grammar has no problem. Okay, and there are two things we need to consider and decide. Okay, first is the logical design. This is more like the data structure selection. Okay, class design. So basically, how many class do you plan to have, and what type of methods that each class needs to support, and so on and so forth. And the second part is implementation. We do this part first and then do this part. Remember, this part is programming language dependent. If you're using Java or Python or JavaScript or C++, the problem is here, okay? Whether or not, hey, what is the Java grammar to do this? Or, these are implementation details. You need to go through this first, and then you'll worry about the implementation problem, okay? And here you need to figure out, okay, I cannot put everything in a single main function, right? And what should I do? Okay, so let's quickly go through the first part, and then we will quickly go through the second part and then see what we do, okay? So, first thing first, let's discuss about the data structure selection. And also the data structure selection and the class design. So basically, how many classes are we going to have, and what are the variables, so on and so forth. So I assume that you have read through the requirement, okay, the project description. So this is what we want. Obviously, there is some type of, you could say it's an array, or it's a table, or it's a sum of type of collection. Okay, the collection, you can use array to implement it, you can use array list to implement it, you can use hash map to implement it. That is your call, okay? But here we need to have a collection. And what are the collection? These are the forward entry. Okay, and you can name it in whatever way you want to name it. And obviously, if you look at the instruction, and here we said, hey, I want to add a entry. I want to add a mail forwarding entry. What are you going to do? You need to input the name, input the old address, and input the new address. So at this time, I'm going to say that, this is my first attempt, or my first attempt that I'm going to design. This is a mail forward entry. I probably should have 3 things in it. The first is the name, the second is the old address, the third is the new address. Okay, somehow I need to read through the user input and create such type of an entry. Okay, and the reason we said it's a collection is because there will be many different nodes in my collection. You could have an array, you could have a linked list, you could have an array list, and so on and so forth. Okay, so you will have a collection of this. And we can clearly see that this is somehow type of a class. And this will be the objects that we create based on the class. And this will be used to store the individual. So each node will be used to store the address. Okay, but each node will store only one entry. Okay, so obviously each entry, each kind of this rectangle will be a class, and the whole collection probably is another class. Okay, we have the individual node, and here I just generally say, hey, this is a node, and the node should have 3 fields in it: the name, the old address, and new address, and obviously each of them is a string. And be very, very careful when you input address. Okay, this is just more of a hint during your implementation. See, the address, there will be space in it. So when you read through your console, read from the screen, make sure you're reading the whole line. You're not just reading a string. If you're reading a string, when the first time it sees a space, it may stop. So you will only read 1132 instead of the whole address. Okay, so be very careful. So the individual node is obviously a class. And then a collection of nodes will be another class. Okay, and I think there might be another class which will be actually the main function. Okay, so now we have decoupled the overall data structure. Okay, so now let's look at each of this data structure and the class independently, okay, or individually. Okay, so the first class will be the node to store the forward address. Okay, So obviously you have the class definition, and we just mentioned that in each of the node you should have 3 fields in it. It stores the name, it stores the old address, and stores the new address. Of course, you need the constructor, you know how to create it. And if you have 3 fields, most of the time you have the getters and the setters. So that would be pretty straightforward, okay? So basically you need to create a class. The class 1 will be the node that actually stores the forwarding address, and it should have 3 fields in it. You have corresponding support methods. And now let's see the second class. Okay. For the second class is the collection of nodes and operations on the node. And we have learned quite some ways to store the collection. You can have the array list, stack. I will be surprised that you choose stack, because obviously this does not have the first in last out property hash map. So anyway, you need a structure that can store multiple of the nodes, okay? And let's look at the function. Okay, somehow you will be able to add nodes. So if you read this, you need to use the constructor to create that node and then add the node into this whatever structure you're using, okay? And be very careful when you choose the data structure, this collection, okay? We never say how large this data structure will be. What does that mean? So I may have a collection contain 100 nodes. I may create a collection of the forwarding address node contain 1,000 nodes, so on and so forth. So you need to take care of this elastic size. So it's okay if you want to choose array, be my guest. But just to make sure that, hey, if you choose an array, make sure you properly handle the expansion thing. So basically, if you have an array, and if you have the original size of 10, and if we try to add 20 entries into your collection of the forwarding address, if you do not handle the elastic size properly, you're going to be in big trouble. Some of you may say that, hey, I'm going to create an array list, array so large that you guys cannot fill it. Watch out, because we can fill it. And not only we can fill it, we can see your source code, okay? So basically, any static sized collection you're choosing, make sure you handle the expansion, okay? There are other data structures that can handle that directly, okay? And of course, if you create that collection, you need to have the constructor. You need to have the constructor. And obviously, you need to have multiple functions. Why? Because if you look at here, you have add. Let me see, where is it? You need to be able to add or remove node from the list, from the collection. Okay, you need to add, you need to remove. Okay, but I do want you to pay close attention, because here it says, if the entry is successfully added, output add. However, there is an error due to the name and old address already existing. The output should consist of the phrase entry already exists on a line by itself. In other words, we do not allow duplicate. We do not allow duplicate entry. What do I mean? So basically, you can have two entries in the collection look like this, which is name is Alice, address 1, and I will forward it to address 2. And if now I add another entry, which is Alice, address 2, address 3, this is okay. This is okay. However, if you're saying, hey, I want to add another entry, so I'm not going to add this entry. So I already have this entry in the list, but I'm going to add Alice, address 1, address 3 into the collection. It will report an error. It will say, basically, these two conflict with each other. Okay, if you want to add this into the collection, you need to first remove this one and then add this one. Well, in this, I'm just talking about like in real life, how should you do that? But in this specific project, if you find out that it's already there, just saying, sorry, I cannot add it. Okay. So if we generalize this a little bit, okay, you may need to consider, so we just described we will have an add and a remove function. And we understand that when you design class, very frequently you may need some supporting functions, supporting method. For example, in this specific case, I'm thinking a find method may be a good way to add into this collection. Why? Because if I have a name and I have the old address input, if I call the find in the add function, I can figure out whether or not it is already there. You can figure out whether or not is it already there. So, so when you call add, if you call find first, and you find that there is already an entry overlap, you can tell the system that, sorry, I cannot add it. Otherwise, if the find returns fail, so basically there's no such an entry, then you can add things in. Similar for remove, okay? If you try to remove something, you need to search in the existing collection as well, and you want to see whether or not it's already there, okay? If it's there, you can remove. Otherwise, you cannot remove something that does not exist in the system. So that's why frequently you will need some type of supporting function into it, okay? And of course, there are many different ways to support the find. Do you treat the find function as a Boolean, which is just return true or false? Or do you treat it as an index that actually return this node? Or just to return the index of node is your implementation detail, okay? The last part, of course, there will be a main function or the user interface. Okay, so the user interface probably existing in your main function. And this main function do several things. Of course, you need the first thing you need to do is to initiate a data structure. So basically, you have a collection, you need to create the empty collection. At the very beginning, there's nothing in it. But you do need to create the collection so that we can add nodes into it, right? And then you will take command. Okay. For this part, do a little bit of Google search and see how Java read line from the command or from the console. I hope this is correct spelling. Okay, read the command and you immediately print it out and see whether or not it's correct, okay, during your debugging and programming procedure, okay. Read the command and then you can differentiate if it's add or remove or mail or quit, okay. So obviously this will be a loop because you need to repeatedly take the command until you receive a quit. So basically, you can have a for loop, you can have a while loop, or whatever loop you want to do. So basically, it's wait for the quit. If the quit does not show up, then you will just stay there. Okay, if the quit does not show up, just stay there. Okay, keep reading more of the command. And if it's not quit, you want to see is that add or remove or mail. Okay. There is one thing I do want to remind you, okay? There might be multiple entries for the same person. For example, like we just draw Alice, address 1, forward to address 2, and Alice, address 2, forward to address 3. So if this is the case, this is in the collection, if I said, hey, I want to send a mail to Alice, to address 1, it needs to search through the collection, find this one first. I should forward it to address 2, but that's not the end because this might be another forwarding entry related to address 2. So what do you need to do? You need to search it again and find whether or not the address 2 needs to be forwarded again. So if you are sending a mail to Alice at address 1, the actual mail result, as illustrated here, should be Alice address 3. Should be Alice address 3, okay? Because you need to keep looking in your collection until you find the end. Okay? So I do want you to, so with this, I think we roughly described the structure design of this project. I got a feeling that I may provide too much of the information, but we're gonna see. Okay, cool. Thank you.